We're going to be talking about ocular prostheses. So Nicholas Poles and a whole bunch of people around him make at the Royal Brisbane Women's Hospital 10 silicone eye sockets, artificial eyes a year, and around 100 just artificial eyes by themselves. They usually do this by hand. And we know that people are trying to do these ocular prostheses to part around it with 3D printing silicone and other materials instead of doing it by hand. Now, also, we know that some people have been trying to do the eyes, and the team here at the Royal Brisbane and Women's Hospital is trying to do this as well. What they're doing is using Stratasys 3D printers and scanning to scan the eye if the patient has one remaining eye, and then recreating it using a Stratasys color 3D printing. Now, I don't know if that's a good idea, if they have the right certification of the materials and stuff, but going forward, this could be an interesting approach to creating these very lifelike, very true to form prostheses for people that could really very well make their lives a lot easier. So working with this with the Harrison Biofabrication Institute, and yeah, this could be a very exciting application that we could see roll out across a lot of different hospitals for this particular procedure. The next thing is about bridges. This is about the Embrace. Now, the Embrace is a very, very famous statue installed at Boston Common, and it's by Hank Willis Thomas. And it's essentially, the arm, is Martin Luther King Jr.'s arm intertwined with Coretta Scott King, his wife. It's 6 meters by 8 meters, so quite a considerable statue, and it's installed in Boston Commons. The statue itself was made by Walla Walla Foundry, and they made it using voxeljet 3D printers and binder jetting, and they binder jet 608 different panels on the 1 meter by 600 meter by 600 millimeter build volume printer, the VX1000, and they 3D printed these out of PMMA. Then they were turned into a cured shell and cast into bronze. So this is something that has been going on for a long time. It doesn't really get much attention as the direct 3D printing of metals and stuff, but it could be an application that's expanding. Indeed, we're seeing more direct 3D printed metal like DED and WAM being considered for public sculpture and stuff like this. We're seeing people look at material extrusion, large-scale plastic printing for this. And of course, voxeljet has been doing this for quite a while now. So this is this could be an area of some growth and some kind of innovative use in public sculpture and stuff like that. Usually we think of these kind of things as being too big for 3D printing, but hey, if you have a printer like this big voxeljet system, you should break it up to enough parts, and you can make quite large things. So that's, I think, good news for all of us. The next thing is for Velo 3D. So Velo 3D has been trying to break into Europe and has scored a significant victory. The company, Powder Fusion company, has sold 2 systems to Avio. One of them is a Sapphire XC1MZ, and the other one is a regular Sapphire. The 1MZ is a 1 meter high, 600 millimeter diameter build volume powder bed fusion system, and it's going to be used for space propulsion systems, and specifically using nickel-based superalloys. Now, the company is using is Avio, and Avio may not be very, very super well known, but they're very, very important. They employ over 1,000 people, and they work in space propulsion, rocket stages, that kind of thing, launch vehicles. And they do this for the ESA and other companies and entities. They're making the P120 C solid rocket motor for the Vega C rockets. They're also making a booster for the Ariane 6 rocket, and they're a key part of this whole European ESA-based kind of dispense establishment. So it's a big win for Velo to get these guys to use their printers for this kind of a really critical application. And it could be a business that keeps growing, and if they're happy, these guys are going to stay customers for a very long time. So generally a big win by Velo. The next news is also actually European Space Agency related, and this is research by CSEM for ESA on flexible sensors. So what they made is partially 3D printed pivotable or pivot sensor and a flexible sensor, and that can be bent, let's say. And then both of them are strain gauges at this moment, because of course it's the easiest to do. And the idea is that they've tested them under load. One of them 200 times they put it under load, and the other one 5,000 times. There was no degradation in the performance. Meanwhile, using aerosol jet for one part of it, thin film for the other part of it, and also a powder bed fusion part, they were able to reduce the mass, reduce volume, and reduce the number of components, which could be very significant. Of course, you want to put the strain sensor on a solar panel, right, which has to be folded out. Then you can have a solar panel that could work for the whole lifetime, or you can have a sensor that works for the whole lifetime of the solar panel. Every time it's unfurled and closed or whatever, it keeps working. And at the same time, that sensor will not add too much weight to that really crucial part. So that could be, it could be something that they could use much, much wider than this going forward. Using aerosol jet has been used extensively for sensors, and yeah, it's very nifty how they did this, and it's a really great implementation that could really point to a ton of 3D printed sensors for IoT, for space, for transport, for things like bridges and stuff like that. And I think this is really an application that we will see grow in the future. So my name is Joris Peels, and this is another edition of 3D Printing News Unpeeled. I hope you thought this was useful. Have a great day.